Hi students, good evening. So last class we seen the part A discussion regarding plane figures. We discussed about a triangle, right? Today we discussing about circles, right? See, a circle is a collection of all points in a plane whose distance from the given fixed point in a plane has constant value. That means, suppose a circle from a fixed point, so any point on this circle that is a fixed value only, constant value that is known as radius. Right? A continuous piece of a circle is called an arc. See, suppose here this circle consider a continuous piece. Suppose this is known as arc AB, right? This is known as arc PQ. This is known as arc BQ, right? So this and all we call it as arc of the circle, right? All right. Now the points on the circle divide into two parts, right? Two arcs. The arc having smaller length called minor arc and having larger length called major arc, right? Suppose see here this arc you see, this is one arc, this is MAN. MAN is called minor arc. Now if we divide it, now the remaining part you see, that is MPN, another color, that is the major arc, right? Now, the line segment joining any two points on the circle is known as chord of the circle, right? Now, suppose any two point, this M and B, right? Right, we join means this is a chord, right? This is the chord of the circle, or this and this join, this is another chord, right? All right. Now, if this chord, 2 points you join, it passes through the center middle point, then this is called a diameter, right? Chord having maximum length, that is diameter, right? If it passes through the center, right, that is diameter. All right. Now another thing is, suppose a circle, right, you divide like this, then you have a small part and you have a big part. This is known as a minor segment, right? Minor segment. This is known as major segment, right? And this is PQ is a code that divide into two parts, right? Then what is the segment? We analyze different terms we are using circle area. Now another point is the perpendicular from the center of the circle chord that bisects the chord. Conversely, line joining the center, the midpoint of the chord perpendicular to the chord. That means see one chord, right? From the middle, from the center to any chord, you draw a perpendicular. That means perpendicular this. Then if this chord length is A, means this is A by 2, this also A by 2. This perpendicular from the center to a chord that bisects the chord means it divides this chord in equal length, right? That is another point. Now another point is, see, there is one and only one circle passing through the three non-collinear point. See, you have three non-collinear point means it is not in a line. Three different points. It is not in a line. Three different points you consider. Now you draw perpendicular to all these lines. Suppose this is make a triangle. Then AB perpendicular, that is come like this, and this AC perpendicular that come like this, and BC perpendicular come like this. Now keeping this as a center, right, this distance, this distance, this distance all same, and you draw a circle means you get a one circle. This only one circle only passing through these 3 points, right? That only this point, right? That is a in a construction we studied in lower classes, right? Now suppose two circle, right, it's a now two circle intersect 2 points in a line through the center is perpendicular to the common chord. See, if two circles intersect like this, here you can draw a chord, right? This is chord for this circle and also this is chord for this circle. Now center and center you join means that is perpendicular to this common chord, right? This principal axis, center to center line that bisects the chord, as well as that chord is perpendicular to the center to center line. All right. Now another point is, see, equal chords of circle equidistant from the circle, right? That means suppose a circle you drawn, here you drawn a chord, here another chord you drawn. Now from the center, suppose this distance d d1, this distance d2, then d1 is equal to d2 means, that means this is ab, this is say CD, then the chord length will be same. AB is equal to CD. Then what we studied, if distance from the center to chord are equal means that two chords are equal in length. Equal in length. Alright. Next point is equal chords, right? Equal chords of a circle subtend equal angle at the center. That means suppose here one chord is there, with the center it make 60 degree. This chord length say 5 centimeter. Another chord 5 centimeter you, another area you drawn, then that also make center same angle 60 degree, right? That means if two chords make a same angle with the center means that two chords are equal in length, right? That way also we can tell in conveys way, right? Now another question is, see, this is very important. See, one chord, right? Okay, one suppose I draw like this. Now suppose, see, this is one arc p q. With the center it make this is center, right? This is center. Suppose this make an angle theta, then it makes with the back side to draw from p and q to another point, common point line, then this will be theta by 2, right? That means this is poq. Poq is double of PAQ, double of PAQ. Then PQ subtended by an angle POQ, that is angle POQ, that should be double of PAQ, or if this is theta means this is theta by 2, right? All right. So this kind of things you have to remember, right? Angle POQ is equal to 2 times PAQ, or here you can say, see, with the center this is the angle, right? This is angle POQ, angle POQ, this, that is 2 times of this angle, right? Because this is the arc making with the center, this is the from the same point we making to a common point, right? Construction making to a common point. So this knowledge is very important. Lot of problem section A it will asking this kind of. Now next thing is circumference of a circle. What is a circumference of a circle? 2 pi r, right? What is area of a circle? Pi r square. Now another thing is alternate. Now another very important thing, suppose this is a semicircle, right? In semicircle whatever angle you enclose, that is 90 degree, right? See, another circle, semicircle you draw like this, this also 90 degree. The angle, right? The angle in a semicircle is right angle, that also very important, right? And perimeter, this length of the circle is always 2 pi r and area is pi r square, right? So next is, now arc length, very important, right? Suppose suppose one arc, right? enclosed with an angle theta. What is this arc length? This x. X is this length. X is equal to, or we can say x is equal to AB. AB is equal to, that is, to find the arc length, perimeter divided by perimeter divided by 2 pi. 2 pi means 360 into theta. Okay, that is the expression. Or you can say angle is equal to arc length by radius. Then L is equal to arc length is equal to r theta. This is also possible, right? L is equal to arc. Theta is equal to one arc. This is the theta, and arc length, say you take an L, then arc length by radius. Or you can say out of total angle, total perimeter what into subtended part angle, that only arc length. Area also like that only. Suppose arc area, this arc area you need. What is total area? That is pi r square. Out of which angle? Total angle 2 pi or 360, right? Or 360. Pi is equal to 180. Okay, degree measure of pi is 180. Radian measure only 3.14. Now pi r square by 2 pi into. Now what is angle subtended? Theta. This angle suspended is theta. This is the area of sector. Area of sector. This equation only for this equation only length of arc, right? Length of arc. Okay, these two equation you have to by heart, right? Area, sector length, that sector length, length of arc, and area of arc. This and all very important, right? Now regarding cyclic quadrilateral. Suppose in a cyclic quadrilateral, opposite, suppose a quadrilateral you draw, and it enclosing you draw a circle means, then what we can say for this opposite angle, for a cyclic quadrilateral, opposite angles are supplementary. Suppose this angle A, this angle C, angle A plus angle C is equal to what? 180 degrees, supplementary. Now this is B, this is D, angle B plus angle D, what? That also 180. In a cyclic quadrilateral, opposite angles are supplementary. Alright? Alright. So this is all about our plane figures. Here we are finishing the plane figure section. We studied quadrilateral, triangles, circles, right? Different types of quadrilateral we have seen, different types of triangle we seen, different properties of circle we seen, right? Now we focus on previous years asked questions from plane figures, and then more problems solving from these figures, from plane figures. All right, thank you.